My name is Mani Abrol. I head the R&D division of a startup called Lexity here in Bangalore. And I have here Manju Megwani from Cisco as well. So both of us will be talking about wings to your imagination. Before I start, I just want to, just give some motivation behind this talk and why we are doing this and why we wanted to talk about it. I started out as an engineer, as most of you out here, worked in an enterprise search company for almost 9 years, and then in a company called Verity in California, and then I moved to Yahoo Research, more in a management role and also in a research role. At Verity, what I used to work on was really complex, large-scale solution, dealing with large amount of data, basically a search index and a retrieval problem. And most of the code that I wrote in my early years was in C, C++, and some amount of Java. And the bane of my life at that point used to be debugging stack traces, memory leaks, crashes, and issues with multiple threads. When I moved on to Yahoo, one of the things that we were inculcated was, okay, there is a set way of doing things. Use these tools. This is what the company uses. Just use these, right? There wasn't a lot of flexibility on what you could do. Once I got bored of being in the management role, I really wanted to go back to my engineering roots, and I joined a startup. And I wasn't sure how it was going to turn out. So initially, I thought that the startup was started in Mountain View about 3 years ago, and I joined as an individual contributor. I said, I'll write code, I'll build something that I'm really passionate about, and then we'll see how it goes. Believe me, I was really scared because I hadn't written real bits of code for quite a few years, and of course things have changed dramatically, right? But I was used to be really afraid of asking questions of the junior engineers, and they would think, oh, my goodness, she doesn't even know this, right? I'm sure most of you have been there, even have to deal with even in your current organizations. But you know what? It was perfectly fine. I thoroughly enjoyed it. I worked on Python, completely new to me, built something in a few months, and I got immense satisfaction out of this. Then, I started to hire, and one of the things that I found, I wanted to hire people who had a certain set of skills, which were new, really new technologies, right? Cutting edge technology, building something quick and dirty. We're in a startup. I need to build something in 2 weeks and put it out there for customers. And I found that lacking in almost every resume I saw, right? There's a lot of, don't get me wrong, C, C++, Java, these traditional systems are great. They solve real problems. But technology is really moving on. And I was looking for skills, which I'll talk about, and I really didn't find them. So I thought, just a couple of hours before the deadline for the GSC submission, I came up with the idea that let's talk about this. Let's talk about the newer technologies and basically give wings to your imagination. If you just want to write up something, develop something in a week, how do you do it? Right? It doesn't have to be 2 months of design before you can start write the first line of code. So that's one of the reasons I want to talk about, and I think Manju also, from the hardware background, hardware doesn't have to be very hard, right? And it's very easy. So the way we split up is I'll talk about software techniques and technologies, some of the new things you've probably heard about them. And then Manju will take on from there. Okay, so let's see. What is the typical web application architecture? How many of you here have built like a web application? Okay, so quite a few. How many of you have used J2EE? Okay, almost all of those hands that first came up. So in a typical, I'm sure this architecture is very familiar to you, right? In a typical architecture, you'll have the main thing, the main component where the most of the development time goes is the web application server. I'm sorry, not the web application, the application server where the business logic lies, where you have to spend a lot of time designing to get it right. And how does it connect to the database? How do you design your the ORM, or how are your objects going to map to the data that is stored. And that's really where most of the time is spent. You may invest in some kind of a caching mechanism if you've got a really large user base and high scalability and availability requirements. You may connect with some external services and external systems. And then last but not the least is actually the web layer, which is going to serve the application. These are typically the main components. In an enterprise application, some of these may be missing. For example, you may not have a web framework, but your business logic server will always be there, and your data storage will always be there. So I'm just going to talk about different techniques, compare them, what is traditionally done in these, and what are the newer buzzwords that you could probably you may want to know about. Okay. So just talking about the higher level components, and I briefly talk about it. So there's the backend business logic. Traditionally, it's been written in C, C++, or more recently, in the last 10 years or so, J2EE has become much more stable, much more popular. Caching, typically you would do like a memcache, and more recently Redis. Data storage, RDBMS, right? Everybody knows that, everybody believes in it. And then batch data processing, your traditional data warehousing techniques. And then the web frameworks, we just talked about it, J2EE, Hibernate, Struts. Those are the standards these days. So let me talk about the application server. What are the basic requirements, right? It needs to be secure. It needs to be able to deal with attack. It needs to be able to scale to large number of users or large amount of data, and then it needs to have transaction support. You can obviously, there's got to be some users which will be, the triple CRUD operations, right? So you need to make sure that it can deal with the availability and it can deal with transaction support. Typically, most of you, quite a few hands went up in writing J2EE, right? How about C++? Okay, fewer. So everyone knows that, everyone believes in it, right? It's been there for many years, it's very mature. There's a huge support in the number of core libraries available. For example, if you wanted to do messaging, there is a very standard library that you can use for messaging. There are, of course, very well-known and mature ways to connect to persistence layers, right? The ORMs, where you have Hibernate and you've got struts. Typically, the J2EE C server, in a large-scale system, you say, oh, I've got lakhs of lines of code, right? They're very stable. They will never let you down. In case of, if you're developing a mission-critical service. And also great for CPU-intensive processes. But what about Python? Had anyone developed in Python? Okay, so I've just got very few hands up. It is, believe me, much more quicker to prototype in. It's much easy to write throwaway code. You don't have to write, 3 classes before you can actually write one thing that does something, right? Because Python inherently supports multiple programming paradigms. You can do functional, you can do object-oriented within the same few Python files. Whereas Java would traditionally force you into think object-oriented before you do anything. Python lets you evolve as your ideas evolve. So one of the reasons Python is very easy to just quickly get something done, because you don't have to spend a lot of time thinking about it beforehand. You can just write, throw it away, write it again. It's very easy to quickly debug stuff. And then it's got very powerful constructs like decorators. Few hands that came up, if you guys use decorators, it just makes your code very readable. There are tons of decorators out there which you can reuse. If I just wanted to, if I wrote a bit of code that spits out just does printfs, but then I want to make it spit out JSON, right? It's very easy. I just use a decorator. But the problem is Python is not, it has some shortcomings which may or may not make a difference to your application. For example, it has this global interpreter lock. What that means is that if you're writing a multi-threaded application, you may not be able to leverage a multi-core processor. So it has a lock. So that is why, in my previous slide I said that you really cannot do CPU intensive. I mean, Java, C++ is great for CPU intensive. But you know what? These days, how many of you write only CPU intensive programs, right? Most of the time you're waiting on I/O. Either you're reading or writing to the DB, or you're reading and waiting for a network connection, right? So it doesn't matter. Most of the time, it doesn't matter. And the other one is garbage collection. In Python, the garbage collector is time-based, and it's not based on, garbage collection is based on a level, right? It'll start collecting, start doing the cleanup only if the memory exceeds a certain amount. Whereas in the case of Java, what you're familiar with, it's more scheduling-based. So what happens is if you're running something in Python which is really long running, and you're actually running a memory-intensive process, you will run into issues. And then another thing I just mentioned, the CPU intensive, right? It is slower than Java, I'm not denying that. But in most cases, most of what you want to do, it may not be CPU intensive. So besides all of these things, besides all the cons, if you think about it, the use cases where Python is used really extensively is Mozilla services. Yelp is all written in Python. YouTube is written in Python. Google uses a lot of Python. One of the famous things that, if you say Google uses, then it must be fine, right? If you're familiar with Mercurial, which is a CVS system, that's also written in Python. And a lot of these are scalable and large-scale systems, right? So it can be done in spite of all the shortcomings. If we move on and talk about the web framework, so I won't talk a lot about J2E. One of the reasons I don't know enough about J2E, but whenever someone talks about a web framework, it's J2E, right? And I think 80% of the resumes that I receive have, people have done J2E of some form or the other beforehand. In Lexity, we use Ruby on Rails. Ruby is newer. It's about 7 years old. It was written by Japanese, and then it became a lot more popular once English translation documentation came about. It's a pure object-oriented programming language, but it's a much higher order. It's got a very clean syntax. I mean, you don't have to do explicit returns. You don't have to typecast certain objects. The typecasting is also dynamic, just like Python. It's quick writing and discard, right? So think about what I said in the beginning. If you really want to develop something quick and dirty, these are the tools that I'm suggesting that you could use. That's the reason, Ruby, because of its clean and easy to write and readability, it's much, much more amenable. How many of you are familiar with Ruby or Ruby on Rails? Okay, a couple, good. And my favorite thing about this is I don't have to worry about memory leaks. I don't have to worry about concurrency. It's all handled by the system itself. Remember, it's interpreted, and it's dynamic typecasting. So that's one of the reasons it becomes so much flexible. Rails is an open source framework which encapsulates which uses the Ruby language basically, and that's the web framework on which your container would run. So actually, let me move to the next slide. So this actually shows you a typical web framework architecture. You've got your container. In the case of J2E, it's your Tomcat servlet container where your business logic would run. Then you've got the MVC framework, which helps separate out the model view and the controller. And then the persistence layer, which helps you model your objects in your application to the database. Both of them are very similar. If you see, it's almost exactly the same. One of the main differences between Rails and J2EE is that in J2EE, you can, some of your ORM mappings, it's just config files, and it generates code. And I haven't honestly used a lot of J2EE, but I've heard about issues where because of the extensive support in the framework itself, it makes it very complicated. Like the code that it generates is much more bigger and very hard to debug. And it might do some strange things that you don't realize. Whereas in the case of Rails, it's more code and less configuration. I wouldn't say a lot more code, but it's slightly, it expects the application developer to be much more explicit when you map your ORM objects. So if you see, like, it's a very side-by-side comparison on what the capabilities of the framework are, but the language is much, much more powerful, much, much more simpler to write and develop in. Okay. Let's go on and just talk about the database layer, which is your storage and retrieval, right? Every application that you write, you've got to persist some amount of data. Traditionally, MySQL, right? MySQL and or the Oracles or the more of the Windows DBs. There cannot be an application without doing some kind of persistence. Now, database management systems came about in the 1960s, and the first relational DBMS came about in 1970s. So think about it, for all of these years, the technology hadn't changed for a long time. You were doing relational DBMS from various vendors for these many years. But why now? Why did NoSQL come about now? One of the reasons is that in the last 10 years, any application that you build, you hope that it becomes widely successful, right? And success in the internet era means that you would have internet-style number of users, right, on that scale, right? So at that moment, your RDBMS will not work anymore, right? So, large DBMSs like, Amazon or eBay don't store in your regular RDBMS, right? It just won't scale. And I'll talk about some of the reasons why. That's why these NoSQL DBs came about, because they solve one of the more core problems in your RDBMS, which is about scaling up. And some of the NoSQL features are, you don't have to define a fixed schema, right? Just like I talked about in the very beginning, you don't have to go through intensive design cycles before you start writing your lines of code. You can write something, use a change your schema on the fly, and keep moving on. That's what NoSQL, one of the features of NoSQL is. And of course, and the biggest one is it's able to scale horizontally. And I'll talk about so again, scaling up, right? If you've got a large data set in a store,